Good afternoon, I'm Emily Bridges. I'm Judy Kishore.
And I'm Joseph Tito.
And our project was Android app security analysis.
Who here has smartphones? About half of you. Who has an Android? A quarter of you.
When you download an app from the Android market, you're presented with an installation screen that details the permissions the app is going to ask you. Now, who actually reads those permissions? I know I didn't before this project. But when you don't read the permissions, you don't actually know what you're downloading. One of the apps we analyzed, Lock, which is just a simple app that offers password protection for the user's apps, not only requests the permission to view your SMS messages, but also to intercept your calls and to find your GPS location.
Okay, so now what does Lock do with this information? As you can see here, that Lock has taken your GPS location, right? So you look here and you see that Lock uses that to get the latitude, longitude of your location, as well as the accuracy of the measurement and the time that you were at that location. That's great. Lock has your information. What's it going to do? You see right here, it says return R1. R1 is actually the compilation of the data I just told you about. What does Lock do with it? It returns it to another function that called it. What could that function be? That function could be an online database, an advertisement library, or anything. It is a leak of your personal information. As a result, it becomes imperative to research and analyze Android app security.
Now for some background on the Android. Android apps are written on an open source platform, meaning anyone can upload apps onto the app market. The most popular app market in the world right now is the Google Play Store, which surpassed Apple as the most popular market in 2011. Some background on Android security. As we said before, Android apps have to request permissions from the user before they can be downloaded onto the device. The apps are supposed to run on the principle of least privilege, meaning that apps do not request more permissions than they require to function. But as we saw with Lock earlier, this is not always necessarily true. Because the Android runs on the open source platform and anyone can upload apps to the market, many malicious apps made their way. To try and combat this, Google created the Bouncer in February of 2012 to read through the source code and look for malicious apps. If a malicious app is found, it is then removed. This is an example of the manifest file. All the apps contain a manifest file, and it details the information about the app. The top is the identification. This particular manifest file is for anonymous email, one of the apps we analyzed. The next part of the manifest file are the intents. The intents are a description of the tasks the app performs. The final part of the manifest file details the permissions, which then correspond to the permissions on the installation screen. This is how the installation screen works. The part to the far right is the part you see when you click OK on the installation screen. The next part are the permissions that the installation screen request corresponds to, and then the API calls, or application programming interface calls, that each permission then corresponds to. This is an example of one of the installation screens. One of the apps we downloaded, Compass, which is just a compass, has the installation screen request of network communication. This request then corresponds to two different permissions, full internet access and to view the network states. These two permissions then correspond to multiple API calls. For example, sending files, downloading files, scanning for Wi-Fi networks, and accessing the Wi-Fi network.
So the purpose of our project were to find apps that are bad, basically. So there are two types of bad apps, overprivileged apps and invasive apps. Overprivileged apps are apps that request more permissions than it actually uses. This is bad because if a hacker were to hack into the app, it already has permissions that you already granted, and it could leak your information faster. Invasive apps are apps that use your data, as seen in Lock, and send your location or personal data out to an outside source, like ad libraries or a database. So the process that we used was we read the description of apps on the Google Play Store and analyzed which permissions they need to run. We then downloaded the app and ran it on the Android emulator from the software development website. We then ran the app and saw what it actually did. Then we hacked into the app using DED and converted the APK code, which is the Android app, to Java, which is readable. We then reviewed the code through Eclipse. However, we found that there were millions of lines of code, and it was close to impossible to analyze all 30 apps. So then we made a shell script which automated the process and found all the API calls. This too was ineffective. So then we went to Stowaway. Stowaway, we uploaded the app, and it gave us two pieces of information. It told us if it was overprivileged, and it gave us the API calls. We then found the manifest file from the APK file by using APK tools. It extracted it. We then compared this to the API calls and checked for discrepancies. These discrepancies were recorded as results.
Okay. After analyzing 30 apps, we compiled the data into this chart. In this chart, you can see green boxes. Green boxes represent the consistency of the permissions over the manifest file and the API calls in the source code. The next thing are the red and orange boxes. Red and orange boxes represent overprivileged apps. To reiterate, overprivileged apps are applications that request too many permissions in the manifest file or are not found in the source code, which includes the API calls. 10 out of 30 apps we analyzed were overprivileged. The red boxes are apps that Stowaway found to be overprivileged, and the orange boxes are applications that we found to be overprivileged through our own analysis of the charts we made. The last and most interesting find of our study were these yellow boxes. These yellow boxes represent permission-protected API calls that are found in the source code, but the permissions that those API calls are required to run were not found in the manifest file. We found this to be curious, as according to the Android developer's website, all permissions an application uses must be declared in the manifest. Otherwise, the application would crash at runtime. Since we had, as Joe said, ran the apps on the emulator, they did not crash. So we concluded that this may have occurred due to the carelessness of the Android app developer. We think that the developer included these API calls in their code, but never called them or referenced them in the main function, and as a result, the permissions were never checked for those API calls, and the application did not crash, and the user did not find anything strange. 9 out of the 30 apps we analyzed proved to have these qualities. The second part of our analysis was to find invasive apps. For this part, we analyzed 5 apps. Out of the 5 apps that we analyzed, 2 apps were invasive, lock and adjust brightness. These 2 apps are very simple apps. As you had seen, lock was just an application to provide password security for other applications on the phone. Lock, as we've seen before, requested the permission for the location. Not only did it request a permission for location, it requested permission to send SMS calls and intercept phone calls. As a result, we delved into the source code. We found that lock actually has hard-coded that it can send SMS messages to other phones and also call other devices. Adjust brightness was another application that we found simple. It was just supposed to adjust the brightness of your screen, make it brighter, make it darker, turn the screen off. When we saw that adjust brightness requested the permission for location, we were perplexed. So we looked into the code, and similarly, just like lock, it took your location, your latitude, the longitude, and the time you were at that location. And what did it do? It probably wrote it to an online database. With Android markets becoming more popular, Android security is important, and it's important that these invasive apps are known to the people. So, for future studies, we first recommend to look into that discrepancy that we found between the permissions with the API calls and the permissions in the manifest file. We also recommend that you allocate enough time to read through all the apps, fully understand what those apps are using for permissions, and what the application requires. As we had some difficulty with our time. The second thing is for your software. We found it was essential almost to use updated software, or else current programs don't run on outdated computers, and that proved to be a difficulty for us. So for future research, we really recommend using up-to-date software. Another another recommendation we have is for the Android system itself. We think that there should be permission changes. These changes can entail better security measures. Better security measures are like the Google's bouncer. We fully support this, and we hope that Android will continue to make its security better. But lastly, this bullet is extremely important. Users must be educated about what they're installing on their device. If they themselves don't understand the permissions, how can Android or anyone else tell them what to do? It's important that you understand what the permissions are, what they can access before installing the application. Otherwise, it can be detrimental to you, your information, and potentially your life. We would like to thank Dr. Vinod Ganapati, Amruta Gopal,
Dean Eileen Rosen, the director of the program, Jean-Patrick Antoine, the assistant director, the Governor's School Board of Overseers, Tara Milan, and the rest of the GSET RTAs, and the New Jersey Governor's School of Engineering and Technology.
In addition, Rutgers University, the State of New Jersey, Lockheed Martin, South Jersey Industries, Inc., and PSENG.